I am back again. I am your usual presenter, Mr. Ibrahim Ajalama, and as usual, I'm going to present on science. And still, we are going to continue on our previous lesson on acids, bases, and salts. As we have just realized, the topic is a very wide topic. This is why it takes us all this time before we can be able to complete it. But I hope so now, in this lesson, from today's lesson, we will be able to complete it and move into a fresh topic, please. So let's all understand it that way now. So we move on now. We start from exactly from where we stopped from the other time, from the other lesson. We are going to look at reaction of acids with bases. Reaction of acids with bases. That is called neutralization reaction. When acids react with bases, that reaction, the name given to it, is called neutralization reaction. And what will explain to you what is neutralization in essence. Here, the effect of the acid will be cancelled and the effect of the base will be cancelled. Now the product that is formed is neutral, which is the salt and the water. They all become neutral. The water will be neutral and the salt will be neutral. So this reaction as a whole is called neutralization reaction. That is reaction of acids with bases to produce salt and water, please. So a chemical reaction happens if you mix together an acid and a base. The reaction is called neutralization. And a neutral solution is made if you add just the right amount of acid and base together. You'll get a neutral solution. Those solution is the salt and the water solution. Good, please, so take note of that. What is neutralization now? What is neutralization reaction? Neutralization reaction. We say this is the reaction between an acid and a base to produce salt and water as a product, please. So this term or reaction is just called neutralization. When an acid reacts with a base to produce what? Salt and water. So never forget this definition from today. What is neutralization reaction? It's the reaction between an acid and a base to form a neutral solution. And the neutral solution is what? Salt and water. For example, I have a base, sodium hydroxide, react with an acid that is called hydrochloric acid. They will produce what? A salt, that is sodium chloride, and water, please. So a base that is sodium hydroxide, combined with an acid that is hydrochloric acid, form what? Salt and water. Now this is H2O, water. This is sodium chloride in essence, sodium chloride as a salt form, please. So take note of that, okay. So metal oxides and metal hydroxide. You know all these are type of bases now already, metal oxides and metal hydroxides. We say metal oxides and metal hydroxide are two types of bases. For example, copper oxide and sodium hydroxide. Copper oxide and sodium hydroxide. Good. A metal oxide is called copper oxide. The other one, metal hydroxide, is what? Sodium hydroxide, NaOH. So all these are bases. Here are general equations or word equations for what happens in their neutralization reaction. That is, when a metal oxide combines with acids, what will be formed? When a metal hydroxide, example sodium hydroxide, react with an acid, what will happen? So we see these equations there already. For copper oxide, we say the formula for copper oxide is what? CuO. React with an acid. The acid we use there as an example is H2SO4, sulfuric acid. Now what is going to be formed here, the product is what? Copper sulfate, CuSO4, plus water, that is H2O, please. So you have seen that there now. This is the reaction. Copper oxide as a metal oxide combined with an acid, this is acid, produce what? A salt. This is copper sulfate. This copper sulfate is a salt and also water. So any substance that is a metal oxide will combine with an acid, it can be any acid, to produce salt and water, please. If you take another oxide here, for example, let's say Na2O. This is sodium oxide, it's a metal oxide. Now let's try to combine with any acid now. Let's try to look at another acid. Let's say HCl. What are we going to have here? Sodium, and this is sodium chloride, and we have water, please. So a metal oxide plus an acid produce salt, in this case sodium chloride, and what? Water. That is H2O. H2O, which is water. So you can use any metal oxide, please. Any element or compound that's a metal oxide can combine with any acid to produce salt and water. If you use copper oxide with sulfuric acid, you are going to have copper, sulfate, and water. If you use sodium oxide and hydrochloric acid, you are going to have sodium chloride as a salt and water. I hope that is very clear now. Good. Let's proceed. Also, let's look at metal oxide, metal hydroxide. This is for metal oxide. Let's look for metal hydroxide. Metal hydroxide. And always remember this. Oxides are always OH with the metal, OH. The metal and the OH, please. So one example of a metal hydroxide is sodium hydroxide. Why? Because this sodium is the metal now. And this hydroxide is now sodium hydroxide, a base. We'll combine with an acid. The acid we use there is hydrochloric acid. And the product is going to be the sodium and the chlorine, sodium chloride. And then this hydrogen and this hydrogen and this, we have H2O, 2 hydrogen and 1 oxygen, 2O, please. So a metal hydroxide, that is sodium hydroxide, react with an acid, hydrochloric acid, to produce salt, that is sodium chloride, and water. So this is how metal hydroxide also react with bases, or acids rather, please. Another is calcium hydroxide, CaOH2, combined with, all right, we have HCl again still. We are going to have now, instead of sodium chloride, we are not going to have sodium chloride. Why? Because we are no more using sodium metal. What we are using is what? Calcium. Calcium hydroxide as a metal oxide, please. So instead now, this calcium and this chlorine, we have calcium chloride, CaCl2, plus what? H2O, water as the products, please. So calcium hydroxide combined with acid give you salt, calcium chloride as a salt, and then water. So this is the case with metal hydroxide. Please take note. Any compound with a metal and hydroxide is a metallic hydroxide, or is a metal hydroxide, like calcium hydroxide, sodium hydroxide, and the acid can be any acids. When they combine, the product will be salt and water. Good. So notice that a salt and water are always produced. Notice that a salt and water are always produced. The mixture usually warms up a little during the reaction too. While the base and the acid combine, the mixture will be a little bit warmed up because it's a chemical reaction now. There will be heat. The exact salt made depends upon which acid and base are or were used. So the exact salt made depends on which acid and base were used. If you use a base with sodium metal and an acid like hydrochloric acid, you will have sodium chloride. Let's see here, if at all now you use H2SO4 here instead of hydrochloric acid, what are you going to have now? You are going to have sodium sulfate, Na2SO4. Because you don't use this chloride now, hydrochloric acid. You are using the sulfuric acid. So the sodium will combine with the sulfate. You have sodium sulfate, and then the end is water, please. So the type of salt or the exact type of salt made depend upon which metal hydroxide you use and which acid you use. Is that clear? Here as well, we use calcium hydroxide. If you use another acid, let's say nitric acid. Let's say H2SO4 here and see. Again, what are you going to have here? You are going to have calcium sulfate. Calcium sulfate as a salt, CaSO4, and then water. We are no more going to have calcium chloride because this chlorine will be out. We are no more using hydrochloric acid, but now the acid you use is what? Sulfuric acid. So the calcium combined with the sulfate gives you calcium sulfate, and you have water produced also there. I hope this point is very clear as well. Okay. Good. Now carbonates and hydrogen carbonates. Again, carbonates and hydrogen carbonates. We start looking with the carbonates first. Any compound with this CO3 is a carbonate, please. So carbonates and hydrogen carbonates are two other types of bases. Remember that we say the metal hydroxides and the metal oxides, and the metal hydroxide are bases. Metal hydroxide are bases. But these are not the only bases. The carbonates are also bases, and the hydrogen carbonates. Please take note of that. Good. They also make a salt and water when we neutralize them with an acid. But this time, we get carbon dioxide gas too. Instead of only the salt and water, we also get carbon dioxide. Whenever acid reacts with carbonates, the product will be carbon dioxide and water and salt. Please take note. The reaction fizzes as bubbles of carbon dioxide are given off. This is easy to remember because we see the word carbonate in the chemical names. These are the general word equations for what happened. We start with the carbonates. Let's start with the carbonates. So acid plus metal carbonate, what are you going to have? You are going to have a salt and water and carbon dioxide, please. Acid plus a metal carbonate. A metal carbonate will give you salt, water, and carbon dioxide. So please take note of this, especially the word carbon dioxide. Which gas is produced whenever acids react with metal carbonates or hydrogen carbonates is what? Carbon dioxide, please. Good. So let's look at the simple equation there. For that, we have HCl, hydrochloric acid, combined with a certain metal carbonate, that is calcium carbonate, CaCO3. This is a metal carbonate. This calcium here is the metal, and this radical is the carbonate now. So it's a metal carbonate. We'll give you what now? The hydrochloric acid react with calcium carbonate, give you calcium chloride, that is CaCl2 plus water and also carbon dioxide. This is what happens now whenever acid react with calcium carbonate. Carbon dioxide gas is given off together with calcium chloride as a salt and water. Please. Okay. Let's go. Now, neutralization. All this we have talked about here is neutralization because acids react with carbonates or metal oxides or metal hydroxide. All this reaction is called neutralization reaction. So take note of that now. Whenever acids react with carbonates, metal oxide or metal hydroxide or metal hydrocarbonates or hydrogen carbonates, that process is called neutralization reaction. And the products are always salt and water. But when carbonates are used, also carbon dioxide will be produced. If only metal oxides and metal hydroxide are used, no carbon dioxide. Remember that. Carbon dioxide is only produced when a carbonate is used with an acid, but not with metal oxide or metal hydroxides. I hope that is very clear. I hope so. Thank you. So let's look at the uses of neutralization. Why is neutralization important? We are going to look at using neutralization or uses of neutralization, or one can say importance of neutralization, or even applications of neutralization. How do we use the process of neutralization in our everyday life? Why is it important? Here are some of the reasons for you now. Importance of neutralization reaction. Number one, we say farmers use lime, that is called calcium oxide, lime, to neutralize acid soil. A soil that is acidic. To cancel out the effect of that acid, we have to apply a substance called lime, which is called calcium oxide, and lime is a base. So applying the base lime on the soil, which is acidic, will neutralize the acid in the soil, and the soil will not be acidic. Now it can be suitable for growing crops and plants. So one can say that neutralization is used in treating acidic soils. Neutralization is used in treating acidic soils. That's number one importance of neutralization. Let me take that back a little bit. Importance of neutralization. So number one we give is by treating acidic soils with lime. Acidic soils by adding lime. Number two, your stomach contains hydrochloric acid. All of us, in fact, our stomach contains an acid, a very strong acid for that matter, which is called hydrochloric acid, which we have discussed here now already, HCl. And too much of this gas, sorry for that, too much of this causes indigestion. If there is too much of hydrochloric acid in your stomach, it will result in a condition called indigestion. And this normally happens, in fact, if you eat food that is not properly chewed or not properly cooked or so, and cannot be properly digested in the system. Therefore, the stomach also produces too much of the acid to help to digest that. So that too much of acid in the stomach will cause a condition or a stomach upset called indigestion, whereby some of the acid, in fact, move up towards your esophagus, causing pain up around your heart. People call it heartburn. It's caused by indigestion. So to cure that indigestion, what do? You have to take some anti-acid tablets. Anti-acid tablets, which contain bases such as magnesium hydroxide and magnesium carbonate to neutralize the extra acid. So in short now, or in brief, we say importance of neutralization is also applied in what? Treating stomach upset. Treating or curing stomach upset. And this stomach upset, we refer to it as what? Indigestion. It's called indigestion. And the tablets used for this purpose is what? Magnesium hydroxide, that is MgOH2, or you can use magnesium carbonate, MgCO3. All these are anti-acid tablets that are used to cure or treat stomach upset called indigestion. Please. Number three, bee stings are acidic. Bees, when they sting you, the venom they put in the skin is acidic. How do we neutralize that acid? They can be neutralized using baking powder. which contains sodium hydrogen carbonate, B stings. So another importance of neutralization is what? Treating bee stings or insect bites as well, okay? By using a substance called what? Sodium hydrogen carbonate, NaHCO3, baking powder, sodium hydrogen carbonate is used in treating bee stings, please. And the process is neutralization because the carbonate here will neutralize the bee sting, which is acidic. The bee sting is acidic, so this is the base, they combine, then there will be a process called neutralization, then you will not feel the pain of the bee sting anymore. Then 4, soluble salts are prepared by neutralization. Soluble salts are prepared by neutralization. Some salts are soluble, and to prepare them, we use a method called neutralization, whereby you add an acid and a base together to produce the particular salt you want or you desired. So then we can also say here, neutralization is applied in what? Preparation of soluble salts. Preparation of soluble salts. So basically, these are the importance of neutralization that we just discussed now, please. So take note of them. Why is neutralization important in our daily life? You can be asked this question in your assessment at any time. State 2 importance or 3 importance of the process of neutralization reaction. To go over them quickly, 1 is treating of acidic soil. Treating of acidic soil, so that is acidic. 2, treating stomach upset, which is called indigestion, by drinking or taking in certain tablets that are called anti-acid tablets, which is magnesium hydroxide or magnesium carbonate. Then 3, neutralization can also be applied in treating what? Bee stings, by using a substance called baking powder, sodium hydrogen carbonate. 4, neutralization is important. Why? Because it's used in preparation of what? Soluble salts. Please take note of these very important points here about neutralization. We move. We're still talking about acids. We have what are called forms of acids. Forms of acids. Acids exist in 2 different forms. We have a strong acid. We have a weak acid. So let's look at that also quickly. We have to fast track things now. We are running against time. Forms of acids. Good. So basically, we have 2 types of acids. We have a strong acid, we have a weak acid. Let's start with the strong acids now. What are strong acids? So the example of strong acids you see there is hydrochloric acid, sulfuric acid, and nitric acid. These are strong acids. Why do we say that they are strong acids? These are the simple reasons you see there. 1, a strong acid is an acid that completely ionizes in water. Completely ionizes in water. For example, the hydrochloric acid you see there. If you dissolve hydrochloric acid in water, what are you going to have? You are going to have 2 ions. You are going to have hydrogen ion and chlorine ion. So it means the hydrochloric acid have completely ionized, completely in the water. Not partially or so, but completely ionized in water. This is why we call them as strong acids. The same way, H2SO4, if you ionize in water, you are going to have a hydrogen ion and what? And a sulfate ion, please. So the hydrogen and the sulfate ion are produced when the sulfuric acid is dissolved in water. So it is ionized. It is already ionized completely. This is why it's called a strong acid. The same thing applies to the nitric acid. Also, strong acids have low pH values of 1 and 2. So take note of that point very well. It's very important. Strong acids always have pH of 2, 1 and 2. pH 1 and pH 2 are strong acids only. 3, 4, 5, and 6 are weak acids. Please take note of that. Point 3, strong acids have high concentration of hydrogen ions. That's why they are strong, because of the hydrogen ions. As I already told you this, the acids, an acid is an acid because of these hydrogen ions. So if an acid has too much of these hydrogen ions, it will be a strong acid. That means high concentration of hydrogen ions, please. Good. So those are what are called strong acids. So take note about those important points there about strong acids. Know the examples first. Examples of strong acids are hydrochloric acid, sulfuric acid, nitric acid. And some of the important points you should know about strong acid is they completely ionize in water. They have pH values of 1 and 2, and they have high concentration of hydrogen ions. Please, those are strong acids. We have weak acids. Weak acids are just as opposite to the strong acids. What are weak acids? Weak acids are acids that do not completely ionize in water. Weak acids are acids that do not completely ionize in water. An example of weak acids is phosphoric acid, H3PO4. Carbonic acid is a weak acid, H2CO3. Ethanoic acid, CH2COOH, ethanoic acid. Citric acid found in citrus fruits, citric acid. So basically, these are examples of what? Weak acids. And why are they weak acids? Simply because, one, they do not completely ionize in water. They cannot completely ionize in water when they are dissolved in water. Two, they have pH value of 3 to 6. Weak acids, their pH value ranges from 3 to 6. So pH 3 is weak acid, pH 4 is weak acid, pH 5 is a weak acid, pH 6 is a weak acid. Take note of that. Then the final point, weak acids have low concentration of hydrogen ions. Remember, we say strong acids have high concentration of hydrogen ions, but weak acids have low concentration of hydrogen ions. So take these points seriously now about strong acids and weak acids. Let me reiterate the once more. What are the differences between strong acids and weak acids? One, strong acids completely ionize in water. Weak acids do not completely ionize in water. Two, strong acids have pH values of 1 and 2. Weak acids have pH values of 3 to 6. 3. Strong acids have high concentration of hydrogen ions. Weak acids have low concentration of hydrogen ions. And know their examples as well, please. I hope those points are also very much clear. Let's also move now. Both alkalis now, again, strong alkali and weak alkalis. Just from mentioning about strong acid and weak acids, the same thing about alkalis also. They can be strong, they can be weak. Good. So let's look at that quickly. Forms of bases or alkalis. We call this as forms of alkalis. They also come in two forms. One is a strong alkali. Strong alkali. An example of strong alkali, as given there, is potassium hydroxide and sodium hydroxide. These are strong bases. And what are some of the reasons why we say they are strong bases? Is one, that they can completely ionize in water. When they are dissolved in water, they will completely ionize. Completely, not partially, but completely. Two, they have pH values from 13 to 14. Strong alkalis always have pH 13 and 14. Please take note of that. 3. Strong acids have high concentration of hydroxide ions. Remember now we are talking about alkalis. So we must mention hydroxide, not hydrogen ion. Hydrogen ion is divided to acids. Now we are talking about alkalis or bases. So we say strong alkalis have high concentration of hydroxide ions. So those are the important points you should note about strong alkalis. They completely ionize in water, they have pH values from 13 to 14, and they have high concentration of hydroxide ions. That is about strong alkalis. Let's look at weak alkalis now. Weak alkalis. An example of weak alkalis is calcium hydroxide and what? Ammonia, NH4, ammonia. These are weak alkalis. Why are they weak alkalis? One, they do not completely ionize in water. They don't completely dissociate in water to form ions. Two, they have pH of 8 to 12. Their pH value range from 8 to 12. So pH 8 is a weak alkali, pH 9 is a weak alkali, pH 10 is a weak alkali, pH 11 is a weak alkali, and pH 12 is a weak alkali. But remember, pH 13 is a what? Strong alkali. pH 14 is a what? Strong alkali. Please, don't forget that. Another point about the weak alkali is what? They have low concentration of hydroxide ions. They don't have too much of hydroxide ions in their solution. That means low concentration of hydroxide ions, weak alkalis. So try to remember these points about strong alkali and weak alkali. I go over them quickly as possible. Strong alkalis completely ionize in water, but weak alkalis do not completely ionize in water. Remember that. Strong alkalis have pH of 13 and 14, but weak alkalis have pH ranging from 8 to 12. Please. Strong alkali have high concentration of hydroxide ions, but weak alkalis have low concentration of hydroxide ions. Please, I hope those points are also very much pretty clear to you now. All right, so note here, very important, note. Concentrated and diluted, we have these two terms that are always confusing to students, and not only to students, even to the grown-up and the elderly. In fact, the terms concentrated, diluted, strong and weak are mostly confusing for most students. So what do we mean by concentrated and what do we mean by diluted? And what is the difference to say strong and weak? So because most often, if we say strong, some students think it's concentrated. Like if you say strong acid, what comes to our mind is always what? A concentrated acid. But this is not the case, please. When we say a weak acid, what comes to our mind most often is what? The acid is what? Dilute. That's not the case, please. Something can be concentrated while it is not a strong acid, or it can be a strong acid when it's not concentrated. An acid can be weak acid when it's not a dilute acid, and so on and so forth, please. So let's try to differentiate between these two, these terms here, so it can be very clear to us now. Now let's say concentrated and dilute refer to the amount of what? Acid and base present in the solution, and not the extent of ionization, that is strong or weak, please. So don't confuse that. Concentrated and dilute are terms used to refer to the amount of acid present in the solution, and not to the extent of ionization, that is to say whether it's a strong or weak acid. No, please. Concentrated means what? A large quantity of solute, in this case the acid, dissolved in a small quantity of solvent, in this case water. Then you are going to have a concentrated solution. When you have large amount of or quantity of the acid dissolved in small quantity of water, you will have a concentrated solution of the acid. So always concentrated acids are corrosive. We have already mentioned that they are corrosive. They can burn the skin, papers, clothes, and so on. You have to understand that. Now, dilute or diluted means a large quantity of solvent, in this case water, that dissolves a small quantity of a solute. If you have large amount of the solvent, more than the solute, that solution is going to be diluted. But that doesn't refer to that it is either strong or weak. No. Strong and weak only refer to the extent of ionization, whether the substance can completely ionize. If it completely ionizes in water, then it's a strong acid or strong base. If it partially or does not completely ionize in water, we can refer to it as a what? Weak acid or weak base. So don't confuse those terms with the terms concentrated and dilute. I hope that also is very much pretty clear. Good. Let's look at this here quickly. Acid rain, because it's a big something very problematic. It's a nuisance to people. Acid rain is in some places where it is very severe. Life is difficult there because most of their crops will die, the animals in the waters will die, and in the long run, they experience famine or hunger, and so. And what causes this acid rain now? If we told you that a rain can be acidic, will you believe that? Yes, of course, it is possible. And how can rain become acidic? We'll explain that as we move on through the lesson now. So acid rain is a rain that is unusually acidic, meaning that it has low pH. You may not easily realize the acidity of acidic rain. Why? Because normally it has a very low pH rand or pH value. So you cannot easily detect it. But most often, rain becomes acidic as it fell down from the clouds. Before it hit the ground, it becomes acidic. How? All right. So now we focus our attention on acid rain. What is acid rain? Most often, when rain falls, before it reaches the ground where we are, it becomes acidic on its way. What causes that? We'll come to learn that as we move into the lesson. But what is the acid rain in essence now? We said acid rain is a rain that is unusually acidic, meaning that it has low pH. This is why it is not often easy to detect an acidic rain because of the low pH value it has. You cannot easily realize the acidity. But most often, rain comes as in the form of acidic rain before it hits the ground, especially in environments where the air is very much polluted. In environments where the air is clean, free of much carbon dioxide, free of much sulfur dioxide or nitrogen oxide, those places don't experience acid rain much. But environments that are very much polluted, they experience acid rain because of the high content of carbon dioxide and sulfur dioxide and nitrogen oxide in the air, which combine with the water to form the rain. And that has become acidic, or acid rain rather. Good. So let's move. So the causes of acid rain. What actually causes acid rain? We said acid rain is caused by emissions of carbon dioxide, sulfur dioxide, and nitrogen oxides. These are very bad gases, simply for the fact that they cause environmental or air pollution. And they are actually also the cause of what? Acid rain. And not acid rain, most often also they are the cause of all these problems we encounter today that is called global warming. The greenhouse effect are caused by these gases that we emit into the atmosphere when we burn fuels, when we burn wood, and so on. Please. So remember here now, acid rain is caused by carbon dioxide in the atmosphere or sulfur dioxide and nitrogen oxide. How do that happen? They react with the water molecules in the atmosphere to produce the acid, as I just said. When the acid rain is coming down from the clouds, the atmosphere containing carbon dioxide or sulfur dioxide or nitrogen, these gases combine with the water to form acid rain. One example I can give you is this carbon dioxide with the water. This is water, that is rain, falling down, and it combines with the carbon dioxide in the atmosphere. What is going to be the product here? It's carbonic acid, H2CO3. So this carbonic acid combined with the rainwater and form acid rain. Acid rain, produced by rainwater combined with carbon dioxide in the atmosphere. Sulfur dioxide also is quite acidic. It can cause this, likewise, nitrogen oxide. When combined with water, it will give acid rain. So take note of that, please. What are the effects of acid rain? What can acid rain cause, actually? So it can have harmful effects on plants, aquatic animals, and infrastructure. Acid rain can cause harmful effects on life of plants. In an area where you have too much of acid rain falling, normally the plants will be killed by the acid, and that's not good for the environment and for people in general and for the animals. Also, it has a harmful effect on aquatic animals, like the fishes in the water. Too much of acid rain falling into the rivers and seas and oceans will kill the aquatic organisms in the water. Okay? Likewise, infrastructure. Acid rain destroys infrastructure. Our houses, the corrugates, and so on, metal objects are mostly corroded because of acid rain. Okay? Good. So we move. Our next topic now is going to be salts. So far, salts. So as I just tell you now, this topic is a very wide topic. This is why it has taken us all this long before we could reach here. But almost we are coming to the tail end now because we have read the salts now. And that's the last part of the topic, salt. Good. So what is a salt in general now? What is a salt? We are all familiar with salts, but the most common salt that we are mostly familiar with is the sodium chloride that we use at home. That is called common salt. But I think from our last lesson, I explained that here, sodium chloride is not the only type of salt. As you just even learned from now. Whenever any type of metal combined with any type of acid, a salt will be formed, please. But not only sodium chloride, that's a salt. So we'll come to see how all these salts are formed. How do we come to have all these different type of salts, please? So in the first place now, what is a salt? We say a salt is always made when an acid is neutralized by a base. So this is why we can define a salt in this way. A salt is a substance formed when the replaceable hydrogen atoms are replaced by a metal. So look at this definition very well about salts. What is a salt? A salt is a substance formed when the replaceable hydrogen atoms. Let me come back here quickly. Of an acid, rather. Atoms of an acid are replaced by a metal, or we say a metallic radical. Example, ammonia. Example, ammonia. So salt is formed when the replaceable hydrogen atoms of an acid are replaced by a metal or metallic radical. Example, ammonia. Let's look at this example here quickly now. We have HCl combined with NaOH. What is going to happen here now? This is acid and this is a base, and this base contains a metal. What will happen here now? This hydrogen atom of this acid will be replaced by this metal, and therefore consequently what will form is a salt. When this metal replaces this, now you are going to have what? Sodium chloride, and then you have water produced. So this salt is produced from where? From the acid. But how? When the metal replace this hydrogen in the acid, then you have the salt. This is why in our definition we said a salt is a substance formed when the replaceable hydrogen atoms of an acid. In this case here, this hydrochloric acid, the replaceable hydrogen atom here is this hydrogen. That can be replaced by this metal from the base to form the particular salt you wanted. So I think that definition is quite well clear. Now we look at examples of salts. Now, all these examples here are salts. One is potassium nitrate. The formula is KNO3, potassium nitrate. The second one is sodium chloride, NaCl. That's the most common one we use at home because it's not poisonous for us. We can consume it without harming us to some extent. Copper sulfate, CuSO4, is a salt. Calcium carbonate is a salt, CaCO3. So basically, there are many more examples of salts here. Like you see there, copper sulfate. Okay, here I show you the example of a particular salt called copper sulfate. And you can see the blue color there. That's why we say always hydrated copper sulfate is blue, but it's a salt. Why is it a salt? Because it's formed from a particular metal that is called copper and from a particular acid called sulfate or sulfuric acid. So we have copper sulfate as a salt. Another good example of a salt is here, sodium carbonate, formed from a particular metal called sodium and a particular acid called carbonic acid. So their combination will give this salt called sodium carbonate. It's a salt, please take note. More example of salts here. We have sodium, or rather calcium chloride. This is calcium chloride. Let me just take one particular pellet from there or lump from there. It's called calcium chloride. It's a particular salt formed from the combination of a particular metal that is calcium and a particular acid that is hydrochloric acid. When they combine, they will give you a salt called calcium chloride. So take note, there are different types of salts. Not only sodium chloride is a salt, please. All right. Now let's look at naming salts. How do we name salts now? Naming of salts. The name of a salt has two parts. What are these two parts now? The first part comes from the metal in the base, and the second part comes from the acid that was used. So to name a particular salt is very simple. What you have to look at is the metal and the acids that combine to form the particular salt, please. So as you see there, the first part comes from the metal in the base used. And the second part of the name of the salt comes from where? The acid that was used. We will see more example as we move on. Example is potassium nitrate. Potassium nitrate. How do you name this salt as potassium nitrate? Why? Because we use the metal and the acid that was used to make this salt, please. So as you see there, potassium comes from a base containing potassium. Example of this can be potassium hydroxide, please. And then nitrate comes from where? The nitric acid. Nitrate comes from where? Nitric acid, please. And therefore, the end product is going to be what? The metal, potassium, and this, the nitrate, which is going to give you potassium nitrate. So we get the name potassium nitrate from the metal in the base and from the acid. Right. Now, the nitrate is comes from the nitric acid. Always remember that nitrate will always come from nitric acid. Sulfate will always come from sulfuric acid. Carbonate will always come from carbonic acid. Please try to remember that, please. Okay? All right. So let's look at the table there. These are just showing you a simple way to remember the names of salts. The first column is acids used, the second part of the salt's name. So anytime you use hydrochloric acid, as the acid in the formation of the salt, the name should end in what? Chloride. Chloride. For example, here is sodium chloride, NaCl. Sodium chloride. The metal is sodium. And this chloride comes from where? The hydrochloric acid. So any salt that is formed from a combination of a metal and hydrochloric acid, the name of that salt should end in what? End in chloride. By first naming the metal that was used. Example, sodium chloride, calcium chloride, potassium chloride. Please. Is that understood? We have sulfuric acid again. If sulfuric acid is used in the formation of any salt, what will happen? The name of that salt should end in what? Sulfate. Should end in sulfate. Example, copper sulfate, sodium sulfate, Na2SO4, and so on. The copper is the metal. Where does the sulfate come from? It comes from the sulfuric acid. Sodium sulfate, the sodium is the metal. But now where does the sulfate come from? It comes from the acid that was used, that is sulfuric acid. So anytime sulfuric acid is used to make any salt, the name of that salt should end in what? Sulfate, please. Nitric acid. When you use nitric acid to make any salt, the name of that salt should end in what? Nitrate. The name of that particular salt should end in nitrate, please. So that's how you name salts. First, you name the metal that was used from the base. Then the second part of the name comes from the acid that was used. Whenever hydrochloric acid is used, the name of the salt should end in chloride. Whenever sulfuric acid is used, the name of the particular salt should end in sulfate. Like just like you see copper sulfate, sodium sulfate. Whenever you use nitric acid, the name of the salt should end in nitrate. Example, let's say potassium nitrate, KNO3. The potassium is the metal, and the nitrate comes from the nitric acid. I hope that is also understood. Good. How can we make copper sulfate? Quickly, the first part of the name is copper. So we need a base containing copper. We could use copper oxide or copper carbonate. For example, the second part of the name is sulfate. So we need to use sulfuric acid. Remember that, because of what? Sulfate. So we have to use sulfuric acid. Good. So these are the equations for that quickly. Copper oxide plus sulfuric acid will give you copper sulfate. Remember that. You can see the metal oxide there is the copper oxide, CuO, is the metal oxide. Combined with the acid, sulfuric acid, H2SO4, give you copper sulfate as the salt. So the first part of the name of the salt is copper, Cu. And the second part of the name of the salt is sulfate. Why? Because it comes from sulfuric acid, please. Copper carbonate the same way. You have copper sulfate when you combine with copper sulfuric acid to give you copper sulfate. All right. Now, the same. How can we make sodium chloride? The first part of the name is sodium, so we need a base containing sodium. We could use sodium hydroxide or sodium hydrogen carbonate. Okay? For example, the second part of the name is chloride, so we need to use hydrochloric acid, please. So there's the equation for that also. Sodium hydroxide plus hydrochloric acid gives you sodium chloride as a salt and water. So NaOH, the metal comes from sodium hydroxide. That's the sodium now. Combined with hydrochloric acid, so the name should be sodium chloride. Because what? You use hydrochloric acid, the name should end in chloride. But why the sodium there? Because the sodium is the metal that comes from the base. Now we say sodium chloride. So acids react with metals and a salt is produced. But unlike reaction between acids and bases, we don't get any water. Instead, we get hydrogen gas, please. This general equation is shown below. Metal plus acids give you salt and hydrogen gas. So we may end our today's lesson here on normal salts. But before we end up the lesson, let's look at some little bit of questions to test our understanding of the various ideas we have discussed here now. But for today, we are going to stop at type of salts. And the type of salts we stop at is normal salts that we call neutral salts. So our next lesson, that's where we are going to start and continue now. So these are the questions. Let's look at them quickly about acids and bases, likewise salts, some aspect of salts. Number one, which of the following substance is a salt? The options given are A, hydrochloric acid, B, calcium chloride, C, sulfuric acid, and D, sodium hydroxide. And the question is, which of the following substance is a salt? What is the correct answer? Is option B. Calcium chloride is a salt. The rest are not salt, they are all acids. Sorry, rather. HCl is an acid, H2SO4 is an acid, NaOH is what? Is a base. But CaCl2, that is calcium chloride, is a what? Is a salt. So take note. Number two, all the following are acids except what? All the following are acids except A, HCl, B, NaOH, that's sodium hydroxide, C, H2SO4, that's sulfuric acid, and D, HNO3, that is nitric acid. So all of them are acids except which one? The option is still B, sodium hydroxide. It's not an acid, but the rest are all acids. Number three, a reaction between an acid and a base is called what? A reaction between an acid and a base is called what? It's called an endothermic reaction. B is called synthesis reaction. C, acidic reaction. And D, neutralization reaction. So the correct answer there should be what? Neutralization reaction. It's the reaction between an acid and a base to produce a what? A salt and water. Number four, which of the following is not an organic acid? Which of the following is not an organic acid? A, sulfuric acid, B, amino acid, and C, palmitic acid, and D, ascorbic acid. So which of them should not be an organic acid? The correct answer should be what? Sulfuric acid, because it's not obtained from living things. It doesn't occur naturally, but the rest all occur naturally in living things, that is plants and animals. But sulfuric acid is not, so therefore it's not an organic acid. 5. The products of the reaction between an acid and a base are called what? The products of the reaction between an acid and a base are called A, salt and base, B, base and water, C, salt and water, and D, water and carbon dioxide. The correct answer should be there, option C, salt and water. The products of the reaction between an acid and a base are called what? Salt and water. 6. Which of the following is not a base? Which of the following is not a base? Hydrochloric acid, sodium hydroxide, calcium hydroxide, potassium hydroxide. So which of them is not a base? Just the first letter option will tell you that from the name acid there, hydrochloric acid. So the answer is hydrochloric acid. It's not a base, but the rest are all bases. 7. Which of the following is not an inorganic acid? Is not an inorganic acid. Carbonic acid, nitric acid, sulfuric acid, amino acid. So the answer is amino acid. It's an organic acid, but not an inorganic acid. So thank you so much, listeners and viewers. This is the end of our lesson for today. I thank you all for your kind attention. And remind you also about the safety precautions. Always wash your hands with soap and water. Always use hand sanitizers, and try as much as possible you stay at home at all time. Thank you very much. Until I come your way again, I am Mr. Jadama once again.